When people encounter a robot for the first time, how do they form impressions of what it can perceive about its environment, what it can see, hear, and understand? We want robots to understand this mental model formation process. We want them to be able to estimate when we've got a misconception, and then understand which actions they can take to nudge us back on track. Our work aims to be a proof of concept that robots can do this autonomously. This is a really difficult problem, so we've started small by formulating an initial approach and building a simple game to test it. In our game, participants choose tasks for the robot to try from a set of diagrams. For example, this one requires following a red line on the floor, whereas this one requires understanding a natural language command. They're then shown a video of the robot trying the task they chose. The robot succeeds at following the red line because it does have an RGB camera, but fails to turn left because it does not have a natural language understanding library implemented. The robot models the human's current beliefs based on which videos they've seen and which tasks they choose. After the human chooses, it's the robot's turn. The game was designed so that the robot needs to teach the human its true capabilities by taking some non-greedy actions in order to get the maximum possible reward. We use a Monte Carlo tree search to choose the robot's next action, and the game continues. The results of our pilot study with 18 pilot participants were promising but not conclusive. We need to compare our algorithm against one that simply chooses greedy actions for the robot, since the human will also learn from this policy, just perhaps not as quickly. After that, we plan to study how the human's beliefs actually update from watching the robot's actions, so the robot can model that more accurately.